Hi students, this is Mr. Yao. Today we're going to talk about 5.1. We'll review and learn some properties about lines and angles, then use them to solve problems. First, definition. Congruent. That means same size and same shape. So for example, if you see the parallel lines on the right side, angle 1 and angle 5 are the same. We will review more what that was called in the next lesson, but they are the same. So we do angle 1. We write an equal sign with a little curly thing on the top to represent they're congruent. So angle 1 and angle 5 are congruent. That means they have the same measurement, they're the same size. Or if we say AB and CD are congruent, that means they have the same length, AB equals CD. Next, vertical angles. So opposite angles when two lines intersect. That looks like this. When two lines intersect, we have these two angles that are actually vertical angles, and then these two angles are also vertical angles because they're facing each other. They're the opposite, on the opposite side of parallel line, of the intersection lines. Vertical angle theorem, vertical angles are congruent. So as you can see, the red ones, these two are congruent, and the green ones, they are also congruent. Right angle, we already know that's an angle that's measured 90 degrees. We use this little square thing to represent. Next, complementary angles, two angles that add up to 90 degrees. So we have, say this is 90 degree, and we have this angle 1 and angle 2. They are complementary because they add up to be this 90 degree angle. Next, supplementary angles, two angles that add up to 180 degrees, and they form a straight line. So let's say we have these two angles, we have angle 1 and angle 2. They form a straight line. And we have angle 1 here and angle 2 here. They add up to 180, so they are supplementary. They're also called linear pairs, two angles that are adjacent and supplementary. So 1 and 2, they are adjacent and they are supplementary, so they are linear pair. But for example, if we say these two, let's say we have an angle here. Let's say we have another angle here. If we say these two angles, let's say they add up to 180, but they're not adjacent, they're not next to each other, so that's not linear pair. They could be supplementary, but they're not linear pair. Next, some more. Midpoint. Midpoint is the point that divides a line segment into two. So here's a line segment, and middle point is right there. That is actually a very important concept that we will use more in the future. Next, postulate. A statement that is accepted as true without proof. The key is postulates are something that we can just use to actually help us to prove something else. Next, theorem or property. An important statement that must be proved before it can be accepted. So it needs to be proved, but we can use the postulates to actually prove them, and then we can use them since we have proven them. So now we have two postulates. Angle addition postulates. The larger angle equals the sum of the measure of its parts. So basically saying, if we have, say, 1, 2, 3, 4, the larger angle is going to equal all of them add together. So because these are the parts, and they add up to equal the larger angle. Segment addition postulates, the larger segment equals the sum of the measure of these parts. So say we have this segment, segment 1, we have segment 2, we have segment 3, segment 4. They all add together to equal the longer one. So these are postulates, which means we don't need to prove them, we can just use them. Now let's have a look at some examples. Number 1, these two angles, they share one point and they are off to each other, or they're facing each other, so they are vertical angles. And if I actually solve it, we just need to set them equal to each other. 4x plus 1 equals 49. Minus 1 on both sides. 4x equals 8. So x equals 12. Now the question then asks us to actually find the angle, so we're just solving for x. Now number 2. These two angles are complementary because they form this 90 degree angle. So complementary That means they add up to 90. So 5x plus 1 plus 4x 8 equals 90. Like terms, 9x plus 9 equals 9x equals 1, x equals 9. That's example 2. Example 3. This angle is given as 90 degrees, and this is a straight line, which means this angle must also be 90 degrees. These two angles are complementary, and that means they add together to equal 90 degrees. We have 8x plus 2 equals 90, minus 2 on both sides, 8x equals 38, so x equals 11. Example 4. Even though we have a bunch of lines, two angles we see right here at this straight line, that means they are supplementary, and they're also linear pair because they're adjacent to each other. So that means they add up to equal 180. So we have 2x plus 132 equals 180. So 2x equals 48. X equals 24. That's example 4. Now example 5. We can clearly see there's a 90-degree angle right there. So angles are going to be complementary. So they add together to equal 90 degrees. 3x plus 14 equals 90. 3x equals 75. X equals 25. Next, example 6. They are sharing just one point and they're facing each other, so they are vertical angles. That means they equal to each other. So 6x equals 78. X equals 13. Next, example 7. These two angles form the straight line, so they are supplementary. That means they add together equal 180. 6x equals 180 minus 18, that is 162. X equals 27. Number 8 is the same thing. They form the straight line, so supplementary. X 3 plus 3x plus 1 equals 100. 4x plus 4 180. 4x equals 106. X equals 44. Next, number 9. The measure of angle EBA. EBA is right here. That is 42 degrees. Angle CBA, which is actually the whole thing together. CBA, that is 18x plus 5. Then we have angle CBE. CBE, which is right here, that's 7x plus 7. So by the angle addition postulates, that means the smaller angle add together, so 7x plus 7 plus 42 is going to equal the larger part, which is 18x plus 5. Combine like terms first, 7 plus 9 equals 8x plus 5, minus 7x on both sides. And move the number to the other side, minus 5. So we got 44 equals 11x. So x equals 4. Next, number 10. Angle DEF. So the whole thing is 181x minus 1. Even though it looks like 180 degrees, we can assume maybe it's just slightly off. We don't know. So let's just write them down as a representation. Next, DEW is 20 degrees. Then we have WEF, 159x plus 1. So same thing, the small parts add together will equal the bigger one. So angle addition postulate 20 plus 159x plus 1 equals 181x minus 1. like terms, 159 plus 21 equals 181x minus 1. 159x on both sides. Add 1 on both sides, so we got 22 equals 22x. So x equals 1. But we are not done. The question is asking us to actually find the measure of angle DEF. So now we need to actually put it back in. So we're going to plug it into here. The measure of angle DEF is 159x plus 1. So 159 times 1, which is 159 plus 1, 160 degrees. That's example 10. Next, example 11. The two parts together equals the bigger one. That is by addition postulate. 2x plus 28 plus 2x plus 23 equals 11. So 4x plus 41, not 41, plus 51, 11. 4x x is negative. That's example 11. Example 12. Find the length of Km. Same thing. We can see the parts by segment addition postulate. 10 plus 2x plus 5 equals x plus 13. 15 plus x plus 13. X on both sides. 15 to the other side. X equals negative 2. Again, we are not done. The question is asking you to find the length of Km. So now I need to put it back Km, which is the whole thing. So x plus 13, which is Km, that is equal to negative 2 plus 13. That is everything for 5.1. Thank you.